Good morning. Good morning, students. How are you this morning? Hello, good morning.
Morning,
Good
sir.
morning.
Good
Yeah,
morning,
morning.
sir.
Good morning, Ali Bali. um, all right. So I did say to you last class that I'm not starting at 8:30, but I normally give 10-15 minutes so that people can you know freshen up and get a little tea to drink or something. So in another 4 minutes, I will begin. Tajay, very good to see you. Kerry Berry, I'm happy to see you again. Kerry, your friend, I don't remember her name,
It's Lorian.
Lorianne, please to call her and tell her it's class time and she must come to class. No,
Yes,
no,
sir.
no, no. And tell her
Okay.
so when she come into class, I want bacons, eggs, and cheese for my breakfast.
Okay, sir.
Thank you. All right. So so in another couple of in about 3 minutes time, we're going to begin and good begin to so give me I'll give you another few just to get your stuff sorted out. Question: where were we the last class? I am trying to remember. We did logarithms. We did the conversion from the logarithmic form to the index form. Um, uh, I recognize that we are continuing because I don't see any first year coming in. Um, where are we? I was in unit two. I was in unit two, but I'm trying to remember, and you guys not helping me at all. Um, what was the last question we did? Somebody, anybody?
Sir, you hearing me right?
I'm hearing you now.
Yes, so I remember doing five log 5 to the 25th.
Log to the base 5 to the 25th.
No, 5 log 5 to the 25th.
Log
So
5.
the log 5 to the 25th was at top like it was the exponent, and the 5 was a big 5.
Um, log 5. Oh, all right, tell me now. Log 5. Log 5. Log 5.
No, sir. 5.
Mm-hmm.
So the exponent was
Mm-hmm.
log 5, 25, right? And then you have the 5. It should have been the base. Or no, it would be the base. The exponent itself, sir, was log 5, 25.
Oh, yeah, yeah, yeah. So it was 5 raised to the log 5 of 25.
Yes, sir.
Oh, so we are, guess what? Guess what? I was looking further up top, so I'm even further below or further ahead than where I thought we were. We're not moving badly at all, guys. This is very nice. We're not moving badly at all. So I was looking further up. Yeah. So we're not doing badly at all. So we're actually evaluating some logarithms. And then no, right. And then Christian was saying, okay, fine. So you see, where I'm at, I'm even going further down because we had done the solutions to those. And I said, oh, so we're now on to, let me share the screen and tell me if this is share screen. and this was the last thing that we did because I had done the solutions to it, right? Log to the base 3, log to the base 3 of 5. Somebody say yes. If anybody's speaking, I'm not hearing you. Hello, 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 somebody. Come on, guys. Somebody just answer me, please. Okay, so I need to fix this. I recognize that there is something here that I need to fix. Um, all right, so no, why am I doing see that I'm supposed to see two of those? All right, so do me a favor, guys. I have the laws of logarithms here. I'm going to read through this law, and I want to read through the first law, and I will come through and explain what I want you to look at for me. So I'm giving you another, I mean, about 2 minutes to read through this for me. Seeing that you're not answering me, let's answer the first one. All right. Now, let us go through the logarithms. Let us go through the logarithms, flows. Let us go through the logarithms. All right, so I need your undivided for a few minutes so that you can see what is happening here. Miss Donnie, I noticed as of late you come class, I don't talk to Serena, but it's all right. There's no love lost between us. See here, Miss D. Let us go through this here. So I am letting log to the base a of b be equivalent to x. So where did you get that from? I am the one introducing that. Just like how when you're cooking and you don't have any scallion, you put extra onion in there because they come from the same family. So you're making a substitute in something or for something, all right? So I am letting log to the base a of b be equivalent to x. I'm letting log to the base a of b be equivalent to x. And I'm also letting log to the base a of c be equivalent to y. So log to the base a of b is different from log to the base a of c, but they relate because they are in the same family. What do you mean by that, sir? They are in the same family of log to the base a. So I have log to the base a of b to be equivalent to x, and log to the base a of c to be equivalent to y. No, both are different, but they belong to the same family. One is log to the base a of b, the other is log to the base a of c. Log to the base a of b is equivalent to x. Log to the base a of c is equivalent to y. So I'm giving you these. So now, what we're going to be doing, therefore, we're going to be doing some little working up. And I think this is part of the problem why my document is the way it looks. So let me just see if I can fix it now. If I cut here, bam, bam, bam. And that's exactly, so I was very right. I was very right with what I was thinking. I also need to cut this somewhere else. Hold on a minute, please. See, I was right again. So that was the reason why for that thing being like that. Let me just all right, so let me just save this. All right, so let us continue. I was having some formatting issues with this thing. I just figured out what was happening. All right, so therefore, no, therefore, I'm converting from the logarithmic form to the index form. Log to the base a of b, I'm converting from the logarithmic to the index form. So can somebody convert this for me, please? From the logarithmic form to the index form for me? Is anyone hearing me?
Yes, sir. We can hear. I can hear you.
Yeah, but I asked a question and nobody's answering me. I asked a question.
I'm trying to follow because remember I wasn't here, so I'm trying to follow.
Yeah, but what about the others? You know, I don't think this is working out. You know, I'm not prepared to spend my Saturday mornings like this. No. Mm-mm. Jesus, intervene, Lord. I'm not prepared to spend my Saturday mornings like this. Is there anybody away from Kerry that is hearing what I'm saying?
Yes, sir.
So why when I ask the question, nobody's answering me? Can you answer the question like I just asked you? Since you hear what I'm saying, can you answer the question that I just asked, please? Kerry, I know you weren't here. So can somebody just answer the question that I just asked, please? This is not working, Jesus.
Sir, what was the question?
And that is my problem. That is exactly my problem. That's the problem, Donnie. That's the problem. That's the problem. All right. Let us again have a conversation before I go. So answer your name. Let us have a conversation before I go, before I continue.
Sir, A
Go ahead.
raised to the X equal B.
All right, thank you, Elizabeth. Thank you, and that's correct. Um, I am not prepared to. I'm not prepared to ask the questions and then turn around and answer them for myself. And let me tell you what is going to happen. And I know that I'm recorded, and I will stand up to this. Let me tell you what will happen. Is it here and out? When I know that I'm not muted and I'm teaching and I ask a question and nobody's responding to me, I will answer myself and I will move on. And I will go through the topic and I will move on. And I want one person says to me, sir, I don't understand. And you will see a different side of the session on that given day. And I'm serious about it. Whenever I'm teaching, I need to hear my students respond. And this is why you are the same ones when you go into town hall meetings that I am not learning online, but what are you putting in? Zilch. You're not contributing. And I'm not speaking about math alone, you know. Because when I speak to my other colleagues, they're saying, Mr. Shad, I'm in class, and I put them, no answer. Last night into my Cape class, I had to stop the Cape class and say, listen to me, this is night. I will go to my bed. I'll find somebody else to teach this class because this is punishment for me. I have a class tomorrow morning at 8 o'clock. And then know when I finished teaching 9 o'clock last night, to wake up for an 8 o'clock class, to come with the same treatment. It's not working out. It's not working out. It's not working out. I have one class this semester that I don't have to ask them to talk. And I want to hear you. I want to hear you. So let me tell you what is going to happen. It's when I ask a question and I wait and nobody answers, I will answer the question and I'm going to move on. And in such a case, I am going to move on very fast. Since it's me alone and because I know the information, I will move on very fast and complete the topic. And I want one person ask me to review. I want one person ask me to review. No more stop it, man. Stop it. It's not happening only for the math classes, it's happening for all the other classes that you are in. Students are sitting in class and becoming spectators. It is frustrating, it is annoying, it is very distasteful, it is not attractive. Stop it. And there are first year students in this class who are coming in and joining the same sort of foolishness. So by the time you reach year 4, it is so ingrained in you. Stop it. In Jesus' name, stop it. Lord, I pray that you just cause me to be relaxed in Jesus' name. Amen. Let us
So,
continue. Yes, Ali,
sorry, can I interject?
go ahead, please.
Um, I hear what you're saying, but for me personally, and my program director knows it as well, because when they just gave me the online learning thing,
Mm-hmm.
they know I don't learn well online,
Mm-hmm.
and they know that I try my best to pay attention online. And then with the whole Mac course there, I would rather all Mac course be face to face, but because of the whole COVID situation, that's not happening.
Mm-hmm.
So I'm not a fan of online learning. And
Mm-hmm.
my program director, my coordinators know of that, and my classmates know of that.
Mm-hmm.
So if I don't speak,
Yeah, but let me ask you, Ali.
I'm trying to.
All right, no problem.
Just
All right, no problem. Let me ask you a question, though, Ali. um, do you like injections? Ali, answer me. Do you like injections?
no, sir.
Okay. So if you are ill and goes to the hospital or your private doctor, and they say to you that I have to give you an injectable antibiotic injectable because it dissolves very well. It moves into the blood system much faster than taking a tablet. And the doctor says, I'm giving you 5 cc's of penicillin for argument's sake. What are you going to say to the doctor? You not
Can
take
I
the
get the pill
injection?
form? Can I get the pill form first?
Okay,
Is
no,
there a pill
no,
form?
no, 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 no. There isn't. There isn't.
Okay.
There isn't.
Um. So
What are you going to do?
I probably don't take the injection.
You probably what?
Probably don't take it.
You probably don't
So
take it.
I've done
Okay,
it.
fine.
Trust me. Yeah.
All right. Okay,
Yeah.
fine. So you are different. Um, the truth of the matter is, why I ask the question the way I ask the question is that right now you don't have an option because there is no face-to-face, which is I'm saying to you that there is no tablet. And if it is that you're sick, and trust me, your answer just now was not truthful because when you're sick and you're in pain, you want that brute to go away, and you're going to say, do anything that you want to do anything that I should be able to get better. All
So
right?
trust me, I've gone to the doctor and refused to get the injection.
Okay, all right, fair enough, fair enough.
Yeah.
You are very different. But for
Very.
me, but for me and my house, whatever it takes for me to feel better, I will do it. And I'm sure there are others here who will say, sir, I don't like it, but I'll have to take it. And for me, and to each his own, I don't take tablets very well because hours, days after, I can still feel the tablet somewhere in my chest, not moving. So give me the injection. I don't like the stick of the needle, but I hate the feel of the tablet trying to go down and can't go down. All right? The truth of the matter is, the point I was trying to make is we don't have anything just now but online teaching and learning. What's the point? We have to make very good use of what it is that we have available. There are times I feel for lobster and caviar and lemon meringue pie and red wine. But when I log onto my online banking system, I realize that I only have $1,000 in my account. And I recognize that I can go to the supermarket and buy a tray of chicken back for $250, and I can pick up a pack of rice, and I can pick up maybe a tin of green peas or sweet corn, and you know that is going to be my caviar, my lobster, because that is my reality at that point in time. I can't sit back and say, oh, I am not eating because I don't have caviar and lobster to eat. So I have to make do with what is available, even though it's not my preference. Even though it is not my preference, but I have to make do. And it may take a while for me to eat the curry chicken back and the vegetable inside of it and the white rice. Because in my headspace, I want that. It's not there, it's not available. So because it's not available, I have to make do with what is available. That's the point I'm making. Now, And by extension, that is part. I was having a conversation with a past student who now resides overseas, came and said, "Sir, we need to link up." And there was a brief link up yesterday. And it's a very conversation we're having. There are some of us here living, and we decide that because it is hype, it is very hip for us to go and drive a new car as opposed to the one that we are driving that is not giving us any problem. But because of our status, the little Toyota Camry, now cut it, we want RAV4 now. You don't owe no money for the Toyota Camry. The Toyota Camry not going into the repair shop. It is taking you from point A to point B. It is very good on field, but because you want to be up there, you want a RAV4. You buy the RAV4, you have payments to make. You can't make the payments, the quality of life gone down. I'm saying to you, make do with what you have. What we have, students, is online teaching. And when you say to yourself, I can't learn using online medium, you think you can learn using it? You have to make that concerted effort. And I'm not speaking directly to you, Ali. I've heard it so many times in my other classes. Sir, I can't learn. This is what we have. This is what we have. We have to make do with what we have. Go ahead, Ali. Yes, Ali.
So I understand what you're saying, but do you know that there are different types of learning? And in
Oh,
order for
absolutely.
somebody to understand the way, I don't have a problem. Well, I do have a problem with online learning, but I also have a problem with maths. I'm good with numbers and I can remember some formulas and telephone numbers and stuff like that. But when it comes on to the working process and the explain, I would rather have a face to face.
Okay, got you.
So
Got you. And there's no love lost in us. So don't internalize it because I made it speaking very strong. I am just very passionate about moving along in the 21st century. And forgive me for stopping the class. You are the cause who caused me to stop the class to talk to you about this, because I really don't want to have to do this again. I remember that very Thursday afternoon when it was announced that we have the first case of COVID in Jamaica. That eventful Thursday afternoon, the 12th of March, and funny story, I would have had a pre-calculus evening class starting at, I think it was 5 o'clock. It wasn't 7 o'clock, it was 5 o'clock, 5 to 7. Or it could be 5 to 9 as a matter of fact. And because I didn't know at the time how to coexist with COVID. And a lot of us were afraid of COVID. Many of us not afraid of COVID anymore. Meaning, when COVID, I didn't want to leave my yard. I looked like a rasta because not even the barbers I would go to. Me must go sit in a barber chair, make barber stand up over me and breathe on me. Now I have a different remedy. Barber don't cut my face anymore. Barber just cut my hair. And when I'm sitting in a chair, I have my mask on. And barber better put on a mask and a face shield. So I know there's no interaction. I don't do any, them don't give me any facial again because I'm not using them hot towel and them something anymore. Last time I went to the barber and said, all right, teach, you just a cut right. He said, yeah, man, I will shave myself. When I first went to the barber about 3 months after COVID, he said, Jesus, Father. And everybody in the barber shop laughed after me. But guess what? I have now learned, and many of us can agree with me, to coexist with COVID. To coexist. So I remember that very Thursday afternoon we had a meeting. I remember leaving the meeting and calling my wife to say, did you hear the news? And she said, no. I said, there's a case of COVID here. And the institution has called a meeting to make a decision. And I want to tell you, the Wednesday I was emceeing a program at the college. Could have been like research day or something of the sort. And one of our students who worked at the airport was at work at the time when the first case, they call it case 0, came to Jamaica. And I was walking up and down with the students inside of the place. You couldn't tell me something about COVID. And then the Ministry of Health apparently contacted the student to say you have to quarantine for 14 days. So when I went to the meeting on the Thursday, I said to the principal, I am moving my class online. And he says to me, Mr. Shand, if that is your position, I have no problem as long as the students are being taught, not a problem. And then my other colleagues said, me, sir, I'm going to move to online too. So when by the time we were in the meeting, the Prime Minister came over and says, effective Friday the 13th, all schools will be closed. But my mind was already made up. And I'm saying to you, do you think I want to teach online? The question is, no, because I'm using a whole lot of resources. See, my student who came, my headset was broken, and I said, let me buy one and send to you so you can carry it back. It is costing me to get my other devices so that I can come across in my whole teaching and learning. So I don't want online either, but this is what I have, and this is what I need to use. So I often say to students, online teaching and learning does not start with me, it will not end with me. Normally, I will say to you, students, how was class today? Is there anything that I can do to improve the online delivery? Tell me, were you hearing me properly? And I think in this very class, sometimes you say, sir, I have end up now with 3 different headsets. So if one not working, I'm switching to the other. Some students say, sir, I'm not hearing this up clearly. I say, all right, hold on. And I'll go switch the device so that you can, because mine is a responsibility to make sure that I create an environment for you that is conducive to learning. Yours is a responsibility to ensure that you come to class so that you can participate and allow, sometimes we are selfish learners because when you ask your question, it helps somebody else in the class who is not understanding. So for example, say Christian understands, or say Elizabeth, since Elizabeth gave me the correct answer, converting from that logarithm form to the index form. Elizabeth knows it. And when I ask a question and nobody's answering, Elizabeth can say, sir, the answer is a to the x equals b. Because what that does at that point in time is to help somebody else in the class who was struggling. The person in the class who is struggling may have had the correct answer on paper, but was afraid to say something. And the mere fact that Elizabeth came out and said that, and I said, very good, Elizabeth. The person who is struggling may say, sir, I had the same thing, but I was afraid of saying it, sir. And it develops a person's confidence. So you who in the class understanding has the responsibility to help somebody else in the class who is not understanding. So we have become selfish learners because we understand. Me not saying we can already understand it. We have become selfish learners. And in this environment, we can't be selfish. We can't be selfish in this environment, You know what is I pray against it. But you know what is very possible? Right now, the ports in the United States of America have trailers there waiting to be filled. So it is that they can go and distribute food on the shelves for the people in the United States. And there are also trailers that are there waiting to be filled so that they can ship internationally. So what those persons in the supply chain market are saying is that we're going to have food shortage for the Christmas season. So the point I'm making, you may say, sir, where are you going with that? The point I'm making is, especially this Christmas, you have to go say to your neighbor, you eat dinner yet? And them say, no, And them say, boy, so one chicken alone I can afford. All right, you buy the chicken, make me buy the ham then. And on a share. So one chicken cut in half of that and the ham cut in half and on a share. This is where we have to go now. And we can't live selfishly. We can have 3 different pieces of meat for Christmas Day, but yet still our neighbor don't have anything, and we feel like, oh, we're having a good time over here. God is not pleased. Just like the classroom, you're understanding, unmute and answer. Then, sir, what if somebody then said, Elizabeth Nuffy, every time she answer the question, okay, fine. If you don't want Elizabeth to answer the question, you unmute before Elizabeth and answer. Come on, students. Come on. Come on, man. I have a love for my students. My student yesterday said to me, Mr. Shan, tell me now, after 20 plus years, why on earth are you still teaching? I said, well, this is what I have. They said, no, sir. Find something. I said, no. Teaching is what I love. Teaching is what I love. I believe I have made quite a number of impacts. Quite a number of impacts. But I really want you guys to come to class, man, and make me feel like, boy, come next week, Saturday, I'll be well, I want to wake up for come to class. I don't want any Saturday morning I have to say, Jesus, class again. Don't want that to happen. This is what we have. And I'm going to ask you to just work with it. Please, just work with it. Do I have a consensus with the class? I need to hear you.
Yes, sir.
Thank you very much. Thank you, Carrie Berry. Thank you, Elizabeth. All right. So I am going to start again. I'm going to start again. For those who may not have heard what I said, I'm going to start again. Laurie, you are not allowed to sneak into my class without saying good morning, sir, especially if you didn't carry bacon, egg, and cheese sandwich for breakfast. All right. Laws of logarithms, starting over. Laws of logarithms. So I'm letting log to the base a of b to be equivalent to x. I'm also letting log to the base a of c be equivalent to y. I'm allowing log to the base a of b equivalent to x, log to the base a of c to be equivalent to y. Now, I want to convert this log to the base a of b equivalent to x from the logarithmic form to the index form. And Elizabeth said to me, sir, it is a to the x equals b. And I would say, very good. And see here, a to the x is equals to b, or equivalent to b. Similarly, if you follow the same response that Elizabeth gave, it would mean that log to the base a of c is going to be equivalent to a to the y equals c. See here, a to the y equals c. So therefore, if I say a to the x times a to the y, hold on, sir, I see it. Sir, if you say a to the x multiplied by a to the y, when you're multiplying and the bases are the same, you add your powers. So a to the x times a to the y is going to be equivalent, sir, to a raised to the x plus y. Let us see. Right, a to the x plus y. But sir, look at what does that mean? Remember, a to the x is equals to b, and a to the y is equals to c. So that means if you multiply a to the x times a to the y, you're going to get a to the x plus y. But you're going to also have that equivalent to b times c. Oh, yes, sir. See here, a to the x plus y equivalent to b times c. So based on what it is that we did, we would have gotten something looking like this. Now, hear my question. Can I now convert this back from the index form to the logarithmic form? Can I convert this back from the index form to the logarithm form?
Yes, sir.
All right, cool. Thanks much. Now I just paused to read a message. All right, cool. No problem, Lori. All right. So this is what is happening. So I'm converting from the index form here, so to the logarithmic form. So remember, the base is always a base. The base is always a base. A is the base, so that means it's log to the base A. So it's log to the base. If watch this now. Tajay, watch this. You weren't here. Kerry, I want to watch this to Honey Bunches. And Laurie, if you can see what is happening here, I want to see because I don't think you were here last week. So watch this now. It's going to be A to the BC. Hold on a minute, please. Sorry about that. But so I'm converting now from the logarithmic, sorry, from the index form to the logarithmic form. So I'm going to have log to the base a, sorry, yeah, I'm correct. Log to the base a of bc is going to be equal to x plus y. So watch this. I was saying earlier, Lori, Kerry, and Tajay, watch this. This is in a base position, so it can't move. The base is always a base, so it can't move. But watch the story. It is this log to the base, this of that equals this. This of that equals this. So you have to move it around. You have to go bam and bam, bam and bam, right and then left, right and then left. So you can't say log to the base a of this because you don't make a move yet. So it's log to the base a of bc is equal to x plus y. See here, log to the base a of bc is equal to x plus y. And then I am going to say, okay, so no, sir, now that we have it in the logarithmic form, where do we go next? And then I'm going to say, but hold on, sir, I see something. X, sir, but sir, you said earlier that x up here, so is log to the base a of b, and that y is log to the base a of c. Oh, sorry. Hold on. So what we have now, so I know that x is equal to log to the base a of b. Oh, come on, things scroll. X is equal to log to the base a of b. So I'm gonna have, so I'm resubstituting this now. X is equal to log to the base a of b. See it right here, so log to the base a of b. And y is equals to log to the base a of c. So see it here, log to the base a of c. So when I substitute all of this, I'm gonna get log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. See it right here, so this is the law. So I'm only developing the law for you. Sir, will I be required at any point in time to show the development of the law? No. I've never seen them ask you to develop the law. What I'm saying to you is, it is important that this is what is important. You see, just like how this piece was important for you to see, and I know you guys see because Elizabeth answered it correctly, converting from the logarithmic form to the index form. Converting from the logarithmic form to the index form. Something just came to mind. Something just came to mind. Let me just see if I can do it to improve the document. Logar, logarit. All right, so I'm moving from the logarithmic form to the index form. Oh Lord, something went wrong right here. So let me just. Yeah, you know what? I don't particularly need that there anymore. All right, so I'm moving from the logarithmic form to the index form and vice versa. This sign here means that I can move from either way, from the index form to the logarithmic form, which is what I really had in orange here. But no, I decided to just put the name here. So moving from the index form to the logarithmic form or vice versa. And this is what this sign means. All right. So let me just save that and then come back down. And remember, guys, every time I send notes to you, always refer to the last set of notes, because just like what I did, I went all the way up here. So on page 3, on page 2, to make a change. Not that what I had before was incorrect, but just to improve on the document as I go along. Why is this thing here? And then All right, so I need to fix this. And then no. So this is similarly should come down. Right. All right. So this is what it is. Log to the base a of b plus log to the base a of c is equal to log to the base a of b times c. What is this saying, sir? When you're adding logs, you multiply. Note, when you are adding logs, you multiply. That's what it is saying. Technically, that's what it is saying. So in little school we say the opposite of addition is subtraction. In big school, when you're doing logarithms, the opposite of addition is multiplication. That's what it's saying. In big school, it's different, because what we're doing is when we're adding, it's going to be multiplied. That's what this is saying. So when you are adding logs, you then multiply, right? So, okay, I know why that happens, because this needs to come up a little bit more. Here you go. All right. So you end up multiplying. See here, sir? Add, multiply. So I don't see no multiplication sign. Yeah, man. In big school, when you have BC, means that it's B times C. All right. Okay. Any questions regarding this first law?
No, sir.
All right, good, thanks. Okay, so let us look at the other variation to it. Let me just copy this since I'm going to use it down here. So copy. Let us look at the other variation. So similarly, when I say similarly, it means I'm going to use the same sort of makeup. Log to the base a of b again is going to be equivalent to x. That will be up top. And log to the base a of c is going to be equivalent to y. That's what we had. Similar makeup. So therefore, converting again from the index form, from the logarithmic form to the index form, we can get a to the x is equals to b. See it here, a to the x is equivalent to b. All right. And then in a similar situation, we can convert this piece from the logarithmic form to the index form. We can have log to the base a of c equivalent to y. So a to the y is equivalent to c. A to the y is equivalent to c. All right. A to the y is equivalent to c. Now, in this case, so all of what we have right here, from here up to here, is exactly what it is that we looked at in the first one. Instead of multiplying a to the x times a to the y, I'm going to now divide a to the x by a to the y. So when we are dividing, and of course, if I divide a to the x by a to the y, I'm going to divide b divided by c. It goes without saying. So look at what is happening. When we divide in indices, once it is that we have an index and we're dividing, and the bases are the same, I am going to be subtracting. How do you subtract, sir? It is always the numerator power minus the denominator power. It is always the numerator power minus the denominator power. So what is happening here is going to be a to the x minus y. See here? A to the x minus y is equivalent to b over c. And having done this, and this is really indices that we have looked at before, so this shouldn't be difficult. And when we do this, we are going to now convert this from the index form to the logarithmic form. And remember, the base is the base is the base is the base. Will never change from the base position. And remember, when you're converting from the index form to the logarithmic form, you know what the base is, that never change, but we have to crisscross. So it's log to the base a of bc equals x minus y. So we crisscross. So log to the base a of bc equals x minus y. See here? Log to the base a of bc equals x minus y. And similarly, we know that x is equal to log to the base a of b. And we know that y is equal to log to the base a of c. So therefore, when we resubstitute, we're going to get this. we're going to get log to the base A of B minus log to the base A of C is equivalent to log to the base A of B over C. Oh, sir, I see what you're talking about now. So when you are dividing logs, when you are subtracting logs, then you divide. So when you're when you're subtracting logs, you end up dividing. And I want you to pay attention to the division. The division is not log to the base A of B over log to the base A of C. Learn this. It is not log to the base A of B all over log to the base A of C. Watch it. The log to the base A is the same as this log to the base A. I have only one to log to the base A. It is the functions that will divide B over C. It is not log to the base A of B divided by log to the base A of C. No, 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 no. It is just one log to the base A, and then we say B over C. Please note. And that's how we end up with something looking like this now. So that's how we end up with this. That's how we end up with this piece. Right? And that's how we got that piece. Log, and this is also
Sir,
go ahead.
so why can't put it over it, sir?
That's not the rule. If you do that, you will get a different answer. That's not the rule. So that's why I'm showing a very good question though. That's why I'm showing you how we develop the law. So you can see the development of this law is saying it's log to the base A of log to the base A of B over C. I'm happy you said that. So teaching at Excelsior, I would have taught in all the schools, in nursing, tourism, cosmetology, in library, because I teach math. So I would teach across all programs. And I remember when I was teaching in hospitality, and I would sit and talk to my students and hear how they would make like a croissant. So I say, why you have to fold? You don't just mix up the ingredients and you mix up. And they said, nope. If you are making a croissant and you don't fold your ingredients in, when you bake that, it will come out to be a rock cake. So I'm saying, but that don't make no sense. That don't make no sense. And I'm saying, yes, sir. When you fold the stuff, sir, you're actually increasing air spaces in the mixture. And you have to fold a particular way because you want as much air in the mixture so that when it bakes with these air pockets, so it becomes, which is what a croissant is. No, you have different types of croissant. So when you have that croissant that is really very well made, it is so flaky and nice, and then they can just fill it with pineapple, strawberry, you name it, and you get those nice croissants, right? And then fast forward now to when I'm teaching over cosmetology, and I had to go into the lab to see how them do them stuff because I'm teaching them math. And I see them section they here to go on what we call cream, and them say, sir, we are no ice cream shop around here, so we relax. And it took a while for me to recognize, say, boy, is relaxed. So every time I'm in class teaching them, I say, okay, so John creams are here, sir. We can't sit down and allow you to say cream, sir, if it's going to be relaxed. And I said, no, Sir Shan, just as how you want these students to learn the principles of mathematics, you have to appreciate their principles. And it took a while for me to understand it, and then I understood it. And then now, because I'm teaching them and I want to make sure that the mathematics that I teach them relates to what it is that they're doing. When they're having their lab class, I have to leave and go to their class and sit down in their class. And I'll say to them, why you have to section the here? Me say, if I am relaxing here, I can just dip my hand in the relaxer that I used to call cream and just massage it in here like how when us men oil in our hair. And they said, no, sir, you have to start from the root and you comb through. And I was like, what? That don't make no sense. And then guess what? I recognize that this is what makes sense for the hair to be relaxed properly. And them tell me what can happen if I do it my way, the client will get burned up, and you don't want that to happen. So I said, okay, fine. So Elizabeth, I gave you those two examples to say it is just a principle of it. If you don't follow the principle, something else is going to happen. If I don't follow the principle in tourism, what is going to happen is that I'm going to get rock cake instead of croissant. If I don't follow the principle in cosmetology, my client is going to have a lot of burns And because I have to wash out the relaxer, the hair is not going to be relaxed properly. All right. And burning up the client can damage the follicle, the hair follicle. And a whole lot of things can happen. So, a cosmetologist is somebody who is supposed to be respected because they understand the science of what is being done. A mathematician also is to be respected because a mathematician will say to you, if you divide log to the base a of b all over log to the base a of c, some evaluation is going to be incorrect because you get a different answer. So what should happen is log to the base a, and you're only dividing the function b over c. So note, when you're subtracting logs, you then divide. When you're subtracting logs, you then divide. And there's one other digger piece that we need to look at. Just one digger piece to look at, right? And then we're going to run into, I'm going to leave you with some examples here to work in class today, and then we're going to have the conversation because I want you to understand what is happening. All right. So here what is happening. So I'm saying to you now, also, we're looking at another thing. Also, log to the base a of b raised to the z n is equal to z. Log to the base a of b raised to the n, so b to the n is a power equivalent to z. So therefore, if I convert this from the logarithmic form to the index form with this power, I'm going to have a to the z is equal to b to the n. A to the z is equivalent to b to the n, which is this line. And then you say to me now, but sir, we can't solve this. The bases are different. The powers are different. And I would say to you, you are correct. You are very correct. The bases are different. The powers are different. You can't do anything. The most you can do is what sir did here. Divide through by the same power for one of them. So I decided to divide through by n. And that's why I put it in red so you can see. So this is going to be z over n and n over n. So when I evaluate that, I'm going to get z over n and 1. And then what I'm going to be doing right here now is to convert from this index form to my logarithmic form. Remember, this is in the base position. The base will never change. The base will never, ever, ever change. So what I'm going to have is log to the base a of b is equal to z to the n. Remember the crisscross? Log to the base a of b, log to the base a of b is equal to z over n. And this is what is it that I'm having here. And then what I can now do is to multiply both sides by this n, because I don't want this like that. So when I multiply both sides by n, I'm going to end up having now n log to the base a of b equivalent to z. See to yourself? N log to the base a of b is going to be equivalent to c. Now n log to the base a of b is going to be equivalent to that. So what is happening here is this. N log to the base a of b is equivalent to z. N log to the base a of b is equal to z. But watch it. Z is equal to log to the base a of b to the n. So when I substitute this value of z, I'm going to have this here. So we now have a law to say log to the base a of b, n log to the, well, log to the base a of b to the n is equal to n log to the base a of b. Log to the base a of b to the n is equal to n log to the base a of b. Sir, explain this. Let us look at this law. Let us look at the one in orange. The one in pink is saying the same thing. So let us look at the one in orange. Log to the base a of b to the n. What is different from this side to this side? Them just take the n and put in front of here so, and them still have log to the base a of b. See here so? Them take off the n from up top here so, and just put it in front of it, and then write back all of the logs. That's all that here is stated. That's all that here is stated. So log to the base a of b to the n is equal to n log to the base a of b. Let me say it one more time. The n here so is just removed and placed in front of it. See here so? And then just write back log to the base a of b. See here? Log to the base a of b. So that's what that is. And those are the laws. Those are the laws. And then I'm going to give you something. This one is what we looked at on Saturday last. Log to the base 9 of 9 to the half. Log to the base 9. See it right here. So we actually did the solution for this. Log to the base 9, 9 to the half. So allow me to just walk you through this again, and especially, oh Lord, especially for those who weren't here. See, I said, Sweetie, we will see this a little later. That's why I have to you know that later is now, or later is here. Where am I looking? I'm looking for bold. So that's why I said to you, we will see this a little later. The reason I did that, because I wanted to come back to that. So what I will do now is just refresh your memory on this one, and then come back to this one now that says later is here. Later is here for this one. So I'm going to talk about this one. All right, so let's go. So log to the base 9 of 9 to the half. We are asked to find the solution to that. We're asked to find the solution to that. Log to the base A, so log to the base 9 of 9 raised to the half power. So what is going to happen? I'm going to let x be the unknown. So it means that I'm going to set all of this to be equals to x. See it here, so all of that to be equals to x. Now converting from the logarithmic to the index form. From the logarithmic form to the index form. It means that 9 to the x equals 9 raised to the half power. The base is the base. Cross. So it's 9 raised to the x power is equals to 9 raised to the half power. Now watch me. I'm saying to you, since the bases are the same, we can equate the powers. So the bases are the same, that means the powers must be equal. So I can say to you quickly that x is equals to a half. So when I evaluate all of this, I am going to get a half. Log to the base 9 of 9 and a half is equals to a half. So that's what it is that we did. All right. So let us look at it. Later is here. Later is here. All right. So I never did it. So let me do it now. So later is here. So using the law that says, copy, using the law that says, all right, come on. All right, hold on. My system is acting up. It does that very well. So using that law, look at what happens. Look at what happens. This a half, copy, paste, equals paste, and then we put the half right here. 1. So using that law, oh crap, let me flip this around. Equal home. All right. So watch this now. Log to the base a of b to the n. We are saying that it's going to be equal to n log to the base a of b. Log to the base a of b to the n is going to be equal to n log to the base a of b. Watch this. The n here come in front of this to form this. And then it is going to have what's left, log to the base a of b, log to the base a of b. So watch me now. Log to the base 9 of 9 to the half. This half going to come in front of this. See it right here, so? And it's going to be equal to log to the base 9 of 9. Now, let me put now down here, so because a story I can tell you. Now, this. No. No. We need to determine the value of log to the base a of a. can somebody in the class work out for me what is log to the base A of A? Sir, how you mean work it out? We did that last class. See here, we get the question to evaluate all of this. We're going to let X be the unknown. I want you to work it out. I don't want to tell you. I want you to work it out.
Sir, isn't one the answer?
Yeah.
Very, very, very good. Excellent. How you got one? Answer me now. How you got one? That's very good. That's very right. But how you got one?
Sir, because of the laws, sir.
Because of the laws. Very good. Okay.
You must
All right.
just no say.
You just math it out, and you know so it's equals to 1. All right. Very good. So what I'm going to do, because okay, there are some students who may be wondering, then oh, don't you get 1? And me in the same class with me, RECALL, and me can get 1. So oh no, undo. So what I'm going to recall here is this. I'm going to let X be the unknown. So what I'm going to have is copy log to the base A is, so I'm going to have log to the base A of A is equals to X. Now converting from the logarithm form to the index form, I'm going to have A to the X equals A. A to the X is equals to A. So I have A to the X equals A. What can I say? What statement can I write now? If A to the X is equals to A, what statement can I write next? Let me see if you're remembering. Háblame. Nobody remembers?
Sir, go again.
Now I'm saying I have A to the X equals A. What statement can I write?
There you can write any power that is raised to the power of x remains the same.
Yeah, right, good. So that means this is A to the first power, right? That's what you're saying.
Yes, sir.
And that would be correct. And then since the bases are the same, we can equate the powers to give X equals 1.
Yes, sir.
Very good. Okay, thank you. So I'm going to have, therefore, X equals 1. Therefore, X is equals to 1. Therefore, X is equals to 1. All right? Now, so I'm going to have X equals 1. So yes, I agree with you, Donnie, that X is going to be equals to 1. So now, where am I, Jesus? Help me, Lord. Okay, so let me just copy back this now. Copy. So now we can say this. So now I can say log to the base 9 of 9 equals
1.
Very good. If log to, you notice what I did? What Sir did was to put something generally, I just gave that general thing because I don't want anybody to, when I say log to the base 9 of 9 is equals to 1, then Sir, what is log to the base 5 of 5? I gave you something generally to say log to the base A of A is 1. Log to the base A of A is 1. So it means if we get log to the base half of a half, it has to be 1. Once the base and what the function is equal to are the same, the answer is 1. So now I can say log to the base 9 of 9 is 1. So I can now go ahead and say this. Hold on, I'm taking that off. Hold on here, hold on. Oh no, oh dear, sorry. Oh. So no, look at what I'm saying. A half log to the base 9 of 9 is the same thing as us saying a half times 1, which is equal to a half. So if you look at it, the question that we did last class, when I said later is now, later is here, right? What is really happening, is us doing it one way last week, and then now learning logarithms, we are able to do the question another way. Another way. All right. So should I tell you the secret now? Or should I tell you the secret later? There's a secret. I'm not going to tell you now. There's a secret. And let me just repeat what I said just now so that you can remember that there is a secret to come. So I was able to do the question this way.
Sir,
Yes, please.
where that one come from? Beside the half.
Log to the base 9 of 9. So this is the same thing as this, log to the base 9 of 9 is 1.
Oh, okay.
Right. So log to the base 9 of 9 is 1. So I'm just saying 1 times a half is a half. So there's a secret. I was able to do this question two ways. I was able to do this question using indices, and I was able to do this question using logarithms. But this question here was done using logarithm now. And the one up top was used doing indices last week, because last week we never looked at logarithms. So we're looking at indices here now. So this is how it is that we got this done up. All right. Now, are there any questions? If not, I have Tajay. Now I need to talk to you, Tajay. So I'm going to actually no, I don't want to do that. I don't want to do that. No. Tajay. No. Delete. Yes. Recreate. Assign manually. Create. Tashi, I want to have a chat with you. So I sent you something, Tashi. So to the breakout. So can you just respond to that, Tashi, please? Look at the screen and respond. Taji, look at the screen and respond. All right, let's come back to you, Taji. All right, so for the rest of you, I want you to do questions 1 through 5 for me, please. I am going over to speak to a student. All right, start for me, please. All right, I apologize for that. I went over to the breakout room and never recognized that it was my screen sharing stopped. All right, so continue working for me, please, all. Please and thanks. All right, I'm stepping in for a few moments. All right. Has anyone completed these questions so far, the first 5? Who's finished?
Sir, I am not quite, but I was asking if you could scroll up, if everyone put up all questions, if you could scroll back up to the first one, first row.
Okay, okay, no problem. Tell me where to stop. That one?
Yes,
Let me
sir.
see. Let me see if I do this, Danny, if it will work. I think if I do that, it works because at least you can see all the questions plus the, well, you're not seeing question 5. So tell me if that works. If just zoom in on your device because it gives you the examples on this side and the questions down here. So tell me if that works for you.
Mr. Shan, sir,
Yes, go ahead.
I'm still in the learning process for this,
Go ahead.
I'm following you when you do all of this just now. But the question, log 3 plus log 4, is it something that you did last week? Because
I just did it. I just did it.
You just did it. So that is how the question would state?
Not necessarily. I'm just trying to build something here to you. I did say too that when you're not seeing a base, to assume what base.
Oh yeah, you said to assume a base, so probably I can use a base as 4.
No, you will assume base 10. No, we did not see a given base, we can assume a base 10.
Oh, so that is what we never understand, sir.
But what is happening here now? What is happening here is the law that I just did, log 3 plus log 4, what I'm trying to switch here. Log 3 plus log 4, I'm saying to you, when I'm adding logs, I'm going to multiply. So log 3 plus log 4, the answer is going to be equal to log 12. So this is what I just did. Log 3 plus log 4, the answer is going to be log 12. Because when I'm adding my log, I'm going to multiply. Right. See here, this is the law. So when I'm adding in logs, the logs must be in the same base. When I'm adding in logs, I'm going to multiply. So that's what I'm giving you. That's the exercise I'm giving you now. So this one here is going to be, the logs are in the same base. Sir, how you know that? Whenever you're not seeing a base written, you're going to assume base 10. So technically what I have here is log to the base 10 of 3 plus log to the base 10 of 4. It's going to be equal to log to the base 10 of 12. So the answer is going to be log 12 right here. And this one here, when you do this one, what do you think the answer is going to be? Number 2.
So when you might,
when it's
still 10 as the base, sir?
Whenever you're not whenever you're not seeing a base, it's in base 10.
10
right. Yeah. Yes, I think that was Tajay. What were you saying, Tajay? The answer is going to be what?
Oh, so I was going to say log to base 10 of 3.
Very good. Log to the base 10 of 3. Excellent. You know why it's log to the base 10 of 3 or log 3? It is log 3 because here Sir just showed you that when you are subtracting your logs, you end up dividing. So it's going to be log 6 over 2. So it's going to become log 3 or log to the base 10 of 3. Same difference. All right. So what I'm giving, the exercise I'm giving you here is based on what it is that we just did. Don't want to do any more with you just yet. I will show you the solutions to those soon. I'm giving you another 4 minutes thereabout to complete 3 and 4, and then I'll come back to you. All right, another 4 minutes.
Okay, sir, understand. Thanks.
Right. So are you finished now?
Up to 4, sir.
You're up to 4? All right, I'll give you a few more minutes. I don't want to just come and do the solutions. I want you to get an opportunity to work. So that's why I am muting so many times. All right, continue working for me, please, because you remember, if you, based on what it is that you see, I have quite a bit of questions and I want us to work on those. So continue working.
Oh, sir, can I show the rest of the questions? Just for a bit, so I can write it off.
Absolutely. Can you see them there? Oh, Lord, let me stop here because I'm showing my answers and I don't want you to see the answers just yet. So let me go to this view. Oh, it would be nice if I could just. All right, guys, I'm going to ask you to hurry because it would be nice if I can show you, start some of these types today and then move into this type. I want to reach here. That's my aim, to reach here, working on some equations today. All right, so those are the Tajay. All right, so while Tajay writes it off and you are working, I want you to listen to me. Yeah, so there are 1 or 2 of you in here that are following what is happening. And for that, I congratulate you and just say that those of you who are struggling behind, that you try to pick up the pace. So when sir upset you, the sir will tell you, but when you are doing very well, trust me, I'm the first to be your cheerleader. So that's very, very, very good. No, continue working very hard. Elizabeth, I have a question for you. But I would tell you when it is. It's one of these questions that I want you in particular to work on based on a question that you asked me. All right, so go on work. I soon come back to the and Tajay, you see, if you finish question 5, don't just stop. I want you to move on to the other questions because what it is that we're doing now is an exercise. I do know exercise so that you can catch up on what is happening. All right, so what you could do, Tajay, is maybe take a photograph of the questions on screen so that I can project back this stuff in using the law so that you can refer to the laws when you're doing the question or questions. So let me know when you've done that.
Oh, yes, sir, I'm finished writing it off now.
All right, cool. So let me just go back to this view so that see what the view look like. Not quite. Not quite. I'm just trying different views to see how. Not quite. All right, so those are the. All right. I've done a few things.
Hey, hey.
All right, so let me go through the first couple of questions and then leave it to do the others. Remembering that I need to get to a particular place today. So log 3 plus log 4. Log 3 plus log 4. When you're adding your logs, you are going to multiply. When you're adding your logs, you're going to multiply. Remembering that you are going to be treating your logs differently from your other forms of calculation, where you know that the opposite of addition is subtraction. In logs, it's different. In logs, it's different. So what we're doing is say log 3 plus log 4 is going to be equal to log 3 times 4. Multiply my logs, log 3 times 4. So look at what I'm going to be doing. Yeah, just multiply. 3 times 4 is 12, log 12. This one here is log 6 minus log 2. When I'm subtracting my logs, I divide. So it's going to be log 6 over 2, which is log 3. And those are they so far. And then log number 3. Number 3 is a little tricky because you have to do several steps to get number 3. You have to do several steps. And those steps now will involve the first part where you're going to say log 2 plus log 6. Now, when we're adding logs, we're multiplying. So log 2 plus log 6 is going to be equal to log 12. So that first part is going to be log 12. Log 2 plus log 6 is log 12. Because you're multiplying the 2 to the 6 to get 12. So what you now have is log 12 minus log 4. So remember now, log 12 minus log 4, you're going to divide. So it's going to be log 12 over 4, which is log 3. And that's how we got the log 3 here. Is everybody understanding what I just said a while ago?
Yes, sir.
Oh, sir, so you have
Yes,
to
sir.
cancel down everything then, sir.
Everything.
You can't leave it as is.
No, cancel it down to its lowest term. Yeah, man.
All right.
Good. That was done here, right?
Yes, it was.
Yeah, good. So let me know now. Is there anyone in the class that is not seeing how I got that one to be log 3 also? All right, so all of you are seeing it. So remember now, it's just for you to follow the procedure. As I said before, this exercise is just for you to see how it is that the logarithms will yes, please.
Question. So if you have the 10 there, will it be wrong?
If you have the 10
I like can remember yourself assume that
oh, if you have log to the base 10 of 3?
Yes.
Oh, no, man, it's not wrong. It's correct.
Okay.
Yeah, log to the base 10 of 3. So whenever you're not seeing a base, assume base 10. So if you put log to the base 10 of 3, I would mark it wrong. It would be still correct. It's the same answer. Very good. All right. Sounding good. Congratulations. When you do very well, I congratulate you. I'm the first to congratulate you. Very well. Now, let us get this thing off my screen.
Sir, you know, see Christian come out.
Christian, come out to the class. Christian, oh no, my Christian is
I'm right here, sir. I'm right here.
No, I
in comment.
In comment, man. Christian, you come out the truth, man. But GSAP, man. Oh, goodness. All right. I'm happy that you're following. I'm happy that you're following. Yes, please. Go ahead. Somebody said, sir. Go ahead. Yes, Donnie. All right, cool. All right. So nice. I am loving it. Congratulations. All right. I want him to say the same thing because this is a CAPE question, you know, in 2009 CAPE question. Me wants a Christian come out with a 1 year. Christian, as a matter of fact, not yet.
Yes.
Let me not drop the gun just yet, because there are others for me to hold you with. All right. So that was number 4. Number 3. Number 4 now. Who got an answer for number 4?
Me, sir.
What is up with the answer?
Log 18.
What you got, Tajay?
Or log 18 as well.
Oh, you got log 18. Anybody else got, let me see if number 4 is right, as log 18. Very good. Now, excellent. I'm proud of you. Proud of you. You know how they got log 18? Watch me. Remember the law that says n log to the base a of b to n log to the base a of b? So log to the base a of b to the n is equal to n log to the base a of b. So they did it backwards. They flip it backwards. Let me show you what I'm talking about, because some people can say, oh, I said I talk about that one here. That's the one I'm referring to. Come on. Okay. All right, so that's the one I'm referring to. Log to the base a of b to the n is the same thing as n log to the base a of b. So what they did, the question was given like this in this form. So that's why I have both forms there. It's the same thing, you know. So they had n log to the base a of b. So what they did, they just put this n up to the b and call it a power. Let me show you. Right here, so them say, things sir can't fool me. This is log 3 squares. That's what they do. They call it log 3 squares, and they are right. They are very right in calling it log 3 squares. So when they call it log 3 squares, what them do is to say, okay, so that means you have 3 squares is 9, so you can have log 9. And when you're adding logs, you multiply. 9 times 2 is 18. Everybody see that? If you're not seeing it, speak up. Very nice calling it. Very nice.
Yes, sir.
Very nice. Ali Bali. Unmute for me, please. Ali Bali. Let me show you how you're going to learn in this online class today.
Yes, sir.
Are you following me?
I'll just log back in, sir.
Ali Bali. Ali Bali, I bet you're not eating dinner today. I bet you're coming here and take your food and you're not eating dinner today.
So if you find the food, that is fine.
Yeah. All right, then cool. Never mind. All right, come. Let us see if we can get it. All right. So this one here, number 5 is pretty much the same thing like we did for number 4. So this is n log to the base a of b. So I'm going to say log to the base 10 of 4 raised to the half power, because this half is going to be over this 4 raised to the power. But what is 4 raised to the half power equals to? What is 4 raised to the half power? It's not a trick question. We've done this before. What is 4 raised to the half power?
2, sir. 2, sir.
Very good. It's equals to 2. Excellent.
4, yeah, fine.
Very good. Excellent. Excellent. So this is going to now work out. All of this work out to the log 2. So log 2 minus log 6. Remember you're dividing. So it's going to be 2 over 6. It's going to give you log 1/3. So number 5 is supposed to be log 1/3. Let me check. Yeah, man. Log 1/3. Very good. All right. And not. Let me do number 6. Let me do number 6, because number 6 going.
Sir, before you do number 6, sir, you can work on number 5 because I'm not seeing it.
You're not seeing it. All right, no problem. Copy. I don't know how to do it, where to do it. All right, let me go right here. This is in columns. Yes, it is. Let me go right here. I'll just place it right here. Number 5. Select.
So the black thing that always are come in front on the screen.
I'm using a software to type, so whenever I go into the software, it comes up like that. Like now, every time I go in the software, it comes up.
Ducks.
All right, Ali. Not Ali. Danny. See there.
Okay.
You see it now,
All
Mary?
right, may I write it down?
No problem. No problem. And the rest of you can do the same thing too. So, so it is important. I know, what's her name? Carrie Berry had a problem, and she would have expressed that concern to me that she couldn't make it for one or two of the classes, and as such, she kind of missed one or two of these stuff. Now, I'm going to say to you, whenever you miss any of the classes, I always upload the recording. So like for classes early today, the recording will be ready for me in another couple of minutes following the class. Go through the recordings, make it your responsibility to go through the recordings, especially if you're not here. It means that you'll be accessing my class asynchronously so that you don't lose out on what it is that sir would have done. Best believe there is no class at all that sir is been missing from the class, right? As long as sir has good health and strength. If there comes a time when sir is not, or when sir comes to class, sir not going to teach anything. If there comes a time when sir can't make it to the class, best believe that I will record your class and upload it to the YouTube channel like I would have done last semester when I was teaching in summer school. I wasn't going to make it for one of the Saturday morning classes, and I recorded my lesson and I created a video and I placed it in the YouTube channel so that when students logged on, they were able to access the class and then ask me the questions the following Saturday. So please, always make sure you go through the and even if you're in class, go through the recordings again. All right, continue working for me, please. Donnie, can I take it off now, Donnie, and project the other questions?
Yes, sir.
All right, good. So I'm projecting the other questions now. Very good, those of you. I'm projecting the other questions that I want you to start working. I'm stepping away. One work, I'll be back.
There, you're not bothered doing number 6.
What was that, Elizabeth?
I'm asking if you're not going to do number 6.
Oh, yeah. Thanks, Beth, for reminding me that I was supposed to do number 6. Whole number 2. When I have whole number, okay, so I'm in log to the base. I'm in log to the base 10. Whole number 2. What do I do with whole number 2? Because we need that for this one here too, for this one here. What do I do for whole number 2? All right, so let me show you something. What is that? You put it in front of the log?
Yes, sir.
All right, hold on.
Because it's a whole number, so go in front of the log.
All right, let me see if I have something here. I wouldn't do it exactly like that. Oh, so there's something here. So come down here. Remember what I just gave you a while ago, log to the base A of A is plus 1. I gave you some rules right here. So you can't say you don't know. All right, let me show you something here. Let me type something here for you. Number 6. Copy. Let me type something there for you. Now, because I'm in log to the base 10, I'm going to say to myself, because I'm in log to the base 10, sir, how you know that you're in log to the base 10? Remember, anytime you're not seeing a base, you're always going to assume base 10. So I'm going to let log to the base 10 of a number. Let x be the unknown. You always say that. Let x be the unknown. Every single time we're going to let x be the unknown. So this 2 here, I'm trying to find what this 2 is in log to the base 10. So I'm going to say log to the base 10 of a number, this unknown, is equals to this 2. So let me just show you what 2 I'm talking about. Let's just say, sir, is it 2 in front of the log 2 log 5? No, that's not the 2 I'm referring to. I'm referring, that 2 is a 2 that I'm color coding. Is a 2 that I'm color coding. So I'm saying let x be the unknown. So log to the base 10 of x is equals to 2. Which 2, sir? The 1 here. Convert this now from the logarithmic form to the index form for me and tell me what you get.
Yes, sir.
Convert this
That's
from the
100.
logarithmic. It's 100. Very good.
That's 100.
Very good. So I'm going to get, oh, come on. I'm going to get x is equals to 100. So I'm going to get x to be equals to 100. So log to the base 10 of a number is going to be equals to 100. So therefore, copy. So therefore, what I'm saying to you now is that all of this is now going to be log of 100. So what I'm now saying to you is that this 2 has the same value now of log of 100. So how you get that? I have to work it out first. The piece in here so is my little workout, my little side work. So now I convert 2 minus 2 log 5 into log 100. So this whole number is going to be log 100. And then I'm not going to tell you how to do the question from here. Finish it. I'm only showing you that part. So what sir is doing is saying I'm converting this whole number 2 because remember, these are 2 different terms. I can't have whole number 2 and log to work in the same breath. So both of them have to be in the same something. So I have to convert this one into log. So I'm saying to you, let x be the unknown. So I'm going to say log to the base 10 of that. Sir, why log to the base 10? Because I'm in log to the base 10. Then, sir, what if this was log to the base 5? Then I will make this to be log to the base 5. So any base that I'm in, I'm going to convert this into the same base. So the whole expression is in the same base. Then, sir, why? Okay, good question. Thanks for asking. You notice all my question here, I'm in the same base. Log to the base A, log to the base A, log to the base A. Log to the base A, log to the base A, log to the base A, log to the base A. So I have to make sure that I'm in the same log. Log to the base A, log to the base A, log to the base A. All right. So everything that I'm doing must be in the same base. So that's why I'm converting it to log to the base 10. But sir, is this in log to the base 10? Yes. Whenever you're not in a base, assume base 10. All right. So that's what it is. So it's going to be log 100. Let me project it this way now so that you can see what is happening. All right. So continue working, please. All right, so tell me now. I want to see how many of you was able to complete the rest of the questions. And you don't have to finish all of it, because I'll give you time enough to go back and do the stuff. So what did you get for number 6? You got what?
Log 4.
Log 4 for number 6?
Yes, sir.
Yeah, man. Very good. Nice. Log 4. What about the others?
Log 100 divided by 10.
Log 100 divided
Number
by?
7. Log 30.
What you get?
25.
Log, make up your mind now. Log 30 for what? For number 7?
7.
Right.
3 times 10.
Okay. All right. So number 7 is indeed log 30. Very good. Tajay, you got log 30. Danae, you got log 30.
Yes, sir.
Sir, I
Nice.
never number the minutes, sir, and I was finishing up one when you started talking. So.
Okay, so this one, look at this one. This one, you got log 30 for that one? You remember it's going to become log to the raised to the 9 to the half. Log.
So I didn't get 30.
All right, that's fine. I like your honesty. Look at this one. It's so funny.
Got 3.
You got 3, no problem. I know. Remember
You
half.
see why I got 3?
Yes, that's why you got 3. But remember, a half log 9 is what we have been working on up here. So sit here. A half log. No, it's a different thing. Sorry. No, it's a different thing. This is a half log 9, not log to the base 9. Okay. So let me work number 7 for you. Let me work number 7 for you. And let me work number 7 for you. Takes 1, 2, 3. 1, 2, 3. Let me work number 7 for you. This is going to be it's going to become a half raised to the log 9 raised to the 1/2.
Sir, when you type in a black, why the black screen comes up?
Because I'm using a software.
Okay.
And then every time I use the software, it opens up in another screen. What I can do is pull the screen this way so it don't block what it is that I'm doing. All right, so I'm opening up another screen. That's why it's 3 squares. So now if you should be able to still see what it is that I have. Come on. All right. All right. So continue following the something's happening. Okay. Continue following the sequence as a type. So when I finish, I can show you what I'm doing. Log 3. All right, so let us do what it is that we have here so far. So a half log 9, that's the part I'm working on first. I'm going to say it becomes log 9 raised to the half power. See here, log 9 raised to the half power. And then I'm going to break up 9 into 3 squares. And then remember the law that says when I have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying both powers. So I'm going to multiply 2 times a half. I'm going to get 1. So I'm going to have 3 to the first power, which is just 3. So that's going to have log 3. Now that I'm finished off with the log 3, there is something else to be done. There is something else to be done. So what sir is going to be doing, what we're going to be doing now is to work out what this 1 works out to be in log to the base 10. What is 1 in log to the base 10?
What is
What,
1? 1
what
is
is
10, sir. 10 to the
very good?
power 1 is 10.
Very good. Very good. So now I can say but I can say but 1 is equals to log 10. I can say but 1 is equals to log 10. Sir, how you get that? Look at what I would have done here up here. So log to the base 10 of a number is equals to 1. 10 to the first number is equals to that number. 10 to the first number is 10. That's what Christian says. CEXAMPL above. All right. So what I now have is going to be log 3 plus log 10. And when you are adding logs, you multiply. So 3 times 10 is 30. So your answer is going to be log 30. Your answer is going to be log 30. Proud of you. Very, very, very good. All right. Look at that. Take a minute or two. Look at it. Ask me the questions before we move on. All right. So that one is log 30. Now you see I got the log 30. Let us look at number 8. No, I'm not doing number 8. Number 8 easy. What's your answer for number 8?
Sir, log 20.
Yeah.
Log 5 over 9 times 36. And 5 times 4 is 20.
Very good. Tajay, you agree with Christian?
Yes, sir.
And I don't agree with none of them. So let me check my answer. Yeah, them right. Log 20 is true. Yeah. All right. So the guys that talk up, the only 2 guys in class tonight. There are 3 of you. One same couldn't make it today. Only 3, the 2 guys in my talk up. Ladies, Lori, you not carrying her breakfast? You not reach home back yet, Lori? Sure, yeah. Lori, stop off. All right. Kerry Berry, I'm not hearing you, Georgie, Georgie,
Sir, I am here. I'm following you. I'm here.
Oh, Trina want me say you stop off, Lori. You make sure answer quick time. You bugger you.
No, sir.
I'm happy that you're with us.
Sir, you just have to just give me today to grasp everything. So next week I'm on fire.
Make sure. All right, good. All right, no problem, honey bunches. Ali Bali, you are way too silent. Ali Bali, wake up. This is the only way we're going to love the on. Ah, thank you. You are with us. You have awoken. Are you following, Ali?
Yes, sir.
Good job. Nice girl. Georgia Porgy Pudding and Pie. It's the boys that made them cry. Not hearing from you.
Sir, I understand.
Okay, great job. Colin, boy. When I get rich, Colin, I'm gonna buy you a computer. One with camera and one with sound. Oh no, you may be at work. Who else is not there? Okay, so everybody else is there. Elizabeth had to run. All right, good. So I'm happy. So you guys are understanding. It's getting warmer. Oh crap, Elizabeth left and I wanted, this question was for her. Oh man. None of you won't get this one right, you know. What's the answer for number 9? Told you. I told you.
The answer for number 9. 29 goes 2 times, sir. But I don't know.
29. Christian, you know what is very interesting? All right, before I go there. Tajay, what do you offer your answer, Pops?
One like I'll see.
You second, Taj?
So Mara said 3. Log 3.
You just said log 3. Told you I was in the catch, you know. Christian. No problem. That's
yes, sir.
You tell
so
me.
I got the same thing.
You got log 3?
Oh, is log 3 not the correct answer? Yes, sir. Or is that not the correct answer?
I feel like I log 6 now.
Tajay, you have one choice, and I'm going to give you the choice now. Which is it? Is it log 3 or log 6?
I'm going to depend. Log 6, sir.
Log 6. All right. Christian, what is your answer? Final answer.
Sir, log 3. Log 3, sir. That's what I get.
Log 3. All right. So Christian get log 3.
3 to 9 is 3. That's what it is.
Okay, so Christian gets log 3. All right. Tajay has log 6. We want the rest of the time to have. All right. Laurie says that she put on the soup. So by the time next week the soup is done cooked. Colin, type your answer. Where you get? Done. Tell me where you get. Georgia Port. All right. Laurie says she get log 2. Colin says she get log 2. Who else? All right. Go Christian.
Yes, sir. I want you to explain how the answer is log 2.
I don't know. I never said the answer is log 2. Don't worry about it. We're going to do it, man. I want to hear from the rest of you. Where is Ali Bali? Ali Bali, what do you get? Let's see. Kerry Berry, what do you get? Georgia Porgy Pudding and Pie, where you get?
They're log 3, but I'm not sure if it's right.
Okay, fine, no problem. Log 3. So I'm hearing log 3. I'm hearing log 2. I'm hearing log 6. I need to hear from Ali Bali, and I need to hear from just Ali Bali. Everybody's Georgia Porgy. Georgia Porgy Pudding and Pie. Georgia Porgy Pudding and Pie.
Sir, log 2.
All right. So log 2, log 3, log 6. Ali Bali, you know.
Log 3, sir.
Log 3. So log 2. Okay, fine. So I hear log 2. I hear log 3. I hear log 6. Log 2, log 3, log 6. Log 2, log 3, log 6. Can I tell a secret? All on the wrong. But I love the energy that you took in it. I 100% appreciate the energy that you took to it. And this is what I love with the class. When I give you a question, we're going to try it. I'm going to see what I want. What I want and what I want. No, I am going to do the question first. And then have a conversation with you about what not to do next time around. But I love it though. Don't think that I'm upset. Nah. When you're learning, mistakes are supposed to be made. Come on, my system is slowing up on me again. Hold on. Come on, system. Come on, come on, come on. All right, here back up. Let me do this so that I can continue. Ah! So that no, I didn't want to paste that copy. I wanted to paste this one.
Sir, may I see? No, sir. So you get log 2.
I don't get log 2 for my answer. I did not get log 2. I did not get log 2 for my answer at all.
And then, oh.
I didn't get a log 2. I didn't get a log 2. I didn't get a log 2. Some people are supposed to eat. Matter of fact, none of them are supposed to eat no dinner today. Not one of them eat no dinner. They must cook the dinner doing and care come give me. I got 2 for my answer. 2 flat, no log. Because I use the law that says log to the base a of b to the n is equal to n log to the base a of b. And I broke up my 9 rather, into 3 squares. So I have log 3 squares divided by log 3. And then log to the base a of b to the n is equal to n log to the base a of b. That means I'm going to carry my 2 in front of the log to the base 10 of 3. So I now have 2 log to the base 10 of 3. But because the 2 is being multiplied by log to the base 10 of 3, divided by log to the base 10 of 3, I'm cancelling out the log 3s. And I'm going to be left with 2 for my answer. This is what I wanted to ask Elizabeth, and know it is again.
So, sir, if I had wrote log 2 in the exam, would I get it wrong or would I get
absolutely no 0? Log 2 is different from 2. Log 2 is different from 2. Yeah, man. Not different too. Yeah, man. Plenty different. Log 2 are a different answer. All right. So now that you see this one, I am going to drop the gun. I'm not going to ask you to do 10 and 11 for me yet. I'm going to give you 2 minutes to do number 12. 2 minutes to do 12, just to make sure that you understand what I just did, and I'll come back to you. I'm going to get some more tea as soon come. What's the answer for number 9? For number 12? I'm seeing something in the chat and I don't agree. What is the answer for number 12?
3, sir. 3.
Okay, okay. Because I'm seeing log 3 in the chat and I'm not agreeing with log 3. I'm agreeing with it 3 alone, not log 3. Check that for me, please. Right, look at it. That's what number 12 is. Very similar to what it is that we did in the number 8, I believe it was. Look at it. Let me know when I can move on. Tell me when I can move. What's the answer for number 10? Anybody try that one? What's the answer for number 10? Anybody try that one? Tajay? Ali? Hello?
Answer could be.
Tajay got number 10?
Oh yes, sir, but I'm unsure.
Don't worry about it. Tell me the answer.
I ended up with log 10 to x. Would that be log x minus log x to the power square to the power 2.
Take it from here for me, please. I think somebody's here to me. 1 minute. All right. So look at what I did. I would have factorized. Remember, it says big school math student, so I have to think outside the box now. And when I factorize, I know that I'm subtracting my logs. So when I subtract logs, I'm going to divide. I know that when I subtract my logs, I'm going to divide. So that's what I should have. And when I divide, the x plus 1 is common to the numerator and the denominator. So that's what I end up having. And when I'm finished with that, I'm going to have log 1 over x minus 1.
Sir, you can fix up that, right? You can bring up the x minus 1.
That's very good. Excellent.
Yes, so I get log minus open bracket x minus 1 close bracket.
To the minus 1, don't forget that.
So I'm not seeing where you get the 1 off the top.
This cancel out, so I've left it 1, not 0. So I cancel this x plus 1 up top, so I'm going to be left with 1. How many times can x plus 1 go into x plus 1? 1 times, don't. Talk to me now.
Yes, sir.
So that's what I did. That's what I did. That's what I did. I'm in a class. I'll call it back afterwards. Yes, please. Or message me. Send me a WhatsApp, please. All right. So so now is there any? Can I go further in that?
So what you mean?
Mm.
In the answer itself?
Can I simplify it any further?
Oh. I don't know, sir, because the question look foreign to me, so.
No, but then what I want you to do is just think outside the box. Think of all that we have done in class today, and see if there's anything that comes out at you.
Well, sir, I guess you could put a -1 in front of the log.
Oh, very good. Excellent, excellent, excellent. That's why I want to talk to me in a class. Because this is excellent. Excellent, excellent, excellent. Or I could just, let me call the one I just put, because I put that -11. So let me just put negative log. And then if you look at it now, you see that's what I have for my answer, negative log x minus 1. So that's very good. Very, very, very good. Wow. That was excellent thinking. Very nice. Love it. All right. What about number 11?
0, sir.
Sir.
Really? I hear 0 and I hear 1. So I can tell you what I hear. I hear 0 and then I hear 1. So tell me which one is it?
Sir, it's the same thing. 1.
Sir, can go back down to the last one, please. The last one.
The last one we just did. Right here.
Oh, okay. Thank you, sir.
No problem. I hear 0 and I hear 1. Which is it? Talk to me, man. Tajay, what do you say? You said 0 down.
Oh, yes, sir.
Sir, I
What was
think
your?
0, sir, because sure me have 1, but now looking at it, I think it's 0.
Why you think it's 0?
Because I have log 8 to 1. So I guess if I turn it
Convert
around,
it.
yeah,
Convert it from
so
the
would
log.
I get the
So,
1?
you don't get the what? Convert that for me, please, Danny.
So if
Log
I
to the
put
base.
the A as the base and 0 as an exponent, I would get the 1, sir. That's what I'm saying.
Okay.
So I was saying I think it's 0.
No,
Not
okay.
1.
So you say that's 0.
Mm-hmm.
Okay. All right. So you're agreeing with Tajay, who incidentally is his first class, so you need to welcome him. But he has been doing very well. So big up yourself,
Yes,
guys.
sir. 0 is the answer.
So 0 is the answer. All right. Nice. So that's how we get 0 for the answer. And if you double check by letting x to be the unknown and say log to the base a of 1 equals x, and you convert that, you're going to have a to the x equals 1. Anything raised to the power 0 is 1. So anything you have raised to the power 0 and you get 1 for the answer, that means that is it. So you can get x equals, that function is evaluated to be 0. All right, so we have, and I want to finish all of these, even at the expense of not going through the other stuff. I just want to make sure that you fully understand all of this thing here. So have you done 13 through 15 for me? Number four, you want to answer me? Let me ask a question. Have you done 13, 14, and 15?
No, sir, I didn't get that far.
All right, good. So, um, so that one is tricky. That one is tricky. So I'm not going to give you any further instructions on that because I want to see if you can figure out the trick. Now, number 15 is also tricky, and that's a Cape 2009 question. Number 15 is also tricky, but because what it is that I would have done now is to give you that last one at number 15 as an equation. The others that we have done were expressions. Now I'm giving you an equation. So I'm going to give you 5 minutes to do 13 and 14. And then we can play around with number 15 afterwards. And then that will take us up to the end of the class. All right, so I'm giving you 5 minutes. All right, so you must be finished now with question 13. You must be finished with question 13, and let us work question 13 together. So remember, when we're adding logs, we do what? When we're adding
We
logs,
multiply.
very good, every single time. When we're adding logs, we multiply. Excellent. That's very, very good. And when we are subtracting logs, when we're subtracting logs, what do we do?
Divide.
Very good. Every single time. This is getting sweeter and sweeter and sweeter as the day goes by. And what is log of 1? Hmm?
0.
Very good. Excelente. Excelente. Very good. So you see that number, you see that number 11 and number 13 works out to be 0. Nice. Let's just go to number 14. Now, if you have 2 log, oh Lord, what do you recognize with this question? What do you recognize with this question, guys?
So that all the bases are different.
Excellent. That the bases are different. All right. The bases are different. Very good. Continue. And what else? What else do you? And what else? Okay, so the bases are different. Let me not even stress it. So, oh Lord, what is happening? So the bases are different. Now, so you recognize we still have this, the whole business of log to the base a of b to the n is equal to n log to the base a of b. So we still have all of that fandangles to work with, right? Log to the base a of b to the n is equal to log to the base a of b to the n is equal to n log to the base a of b. So we have all of that to work with. So what we're going to be doing now is to evaluate what it is that we have here. So we're going to carry forward 2, so we're going to get log to the base 5 of 25 now. Log to the base 5 of 25, and we're going to get log to the base 2 of 8864. 8864. 8864. So this is what we have. So we have to work out each of these individually. Each of these must be worked out individually. So remember what we did? We said, if I'm just trying to let x be the unknown, copy. So you have to work out each of these individually. Okay, so let x be the unknown. Then we have log to the base 5 of 25. Is equals to x, the unknown. So now we're going to have 5 to the x equals, now we're going to have 5 to the x is equal to 25. If 5 to the x equals 25, what is x? 5 to the x is equal to 25. What is the value of x? Teacher? Let x be the unknown. So log to the log to the base 5 of 25 equals x. So 5 to the x is equal to 25. You know that you can have 5 to the x is equal to 5 squares. Since the bases are equal, we equate. The bases are the same, we equate, so we can get x equals 2. Any question?
No, sir.
All right, and then now copy. What I'm going to do is do the same thing. Let log to the base 3 of 27 be equals to x. Log to the base 3 of 27 equals x. So we have 3 to the x equals 27. So 27 is going to be 3 times 3 is 9 times 3. So it's going to be 3 to the third power. So since the bases are the same, we can equate the powers. X going to be equal to 3 in that case. And finally, again, let x equals again, log to the base 2 of 64. Log to the base 2 of 64 to be equals to x. So 2 to the x is so important. The logarithmic form to the index form becomes 64 is the same thing as 2 to the 6. It's so important that thing becomes very, very important. The conversion of the logarithmic form to the index form becomes very important. So I'm going to have 2 to the x is equal to 64. 64 can be written as 2 to the 6. 2 times 2 is 4 times 2 is 8, times another 2 is 16 times 2 is 32, and 32 times 2 is 64. So it's 2 to the 6. So now we have the question, copy, paste, to be equals to 2 plus 3 minus 6. And that's equals to -1. Look at that question for me and tell me if you agree with me or it is that you disagree with me. Talk to me now.
So you say we must look for seats?
No, just tell me if you agree with me.
Oh, that's exactly what I mean.
Yeah. So are you saying that you're seeing it? Are you agreeing with me? Can we move on?
Yes, sir.
All right, good job. And then now we are on to our final question. Huh. Did anybody give number 15 a try? I want to hear it. Did anybody give number 15 a try?
No, sir.
All right. All right, so we have log to the base a of 4 plus log to the base a of x. When we're adding logs, what do we do? When we're adding logs, what do we do?
Multiply, sir.
You multiply. So tell me if you agree with that first line that I wrote.
Yes, sir.
All right, good. So when I'm adding logs, I multiply. So and when I'm dividing logs, what do I do now?
Subtract.
Oh, when I'm subtracting, okay, yeah, I asked the question wrong. You're right. Yeah. Okay, you got me. You got me. Yeah. So we're going to be dividing here in this case because I asked a question for the answer, and you ask me you respond to me with a question. All right, good. So we have log to the base a of 4x over 7 equals 2. Do you agree with that? Yeah, no, maybe
yes,
so.
sir.
Good. And then what's the next step? What would be the next
So
step?
you can put it in exponential form.
Very good. And how do I put this in exponential form? Tell me.
A to a squared and equal 4x over 7.
I like the energy. Then you don't always show up, but when you show up, you bling out. You put on your
Sir, I did show up last week, sir. And I'm always here, sir.
You're always here now. But in the early part of the class, you left me standing alone, and I expected you to show up. Sir, unless, let me hear. That what?
That wasn't what happened, sir. I stepped aside, so I didn't hear the question.
Okay, then I forgive you.
That's what
happened. I forgive you. Very nice. So you now have a squared is equals to 4x divided by 7. Can we go any further? All right. So if they ask us to make x, the subject.
No, you have one side as a fraction here. You can turn the next side into a fraction. Cross multiply. That's how further you can go.
I guess I can put the 2 over 7 on the other side.
Yeah, I mean, if I think the question, I think what I had done with this question in 2007, I think the question was incomplete. I should have said, I think the question had said, in term, find the value of this x. What value of x will make that equals to 2? So let me just put that there. DETERMIN, determine the value. I think that was a question. Determine the value of x that makes, I think that was a question. Determine the value of x that makes log to the base a of 4 plus log to the base a of x minus log to the base that equals 2. It's a K 2009 paper. So we need to find the value of x. So it means that we need to make x the subject of the formula. We need to make x the subject. So how do we make x the subject right here now? I can multiply both sides by 7. Now I'm hearing to get 7a squared is equal to 4x. Tell me if you see that. I'm multiplying both sides by 7. You agree?
Yes, sir.
Mm-hmm.
I
And
divide
then no.
both sides by 4 for x.
Very good. So I'm going to divide both sides by 4 now. Excellent. Dividing both sides by 4 now. And when I do, I'm going to get x to be equal to 7a squared over 4. 7a squared over 4. And I think that's what I got for the answer. 7a squared over 4, yeah. So that's what we would have done for that question. So the question would have read, determine the value of x. Determine the value of x that makes this function equals to, and that's what we'll do. So you recognize, even though the question looks ugly, that it really doesn't change what it is that we would do. We still do the same things that we would have been doing in terms of applying the laws of logarithms, converting from our logarithmic form to the index form. It doesn't change. Now, why I'm giving you all these questions and I'll go into the K-past papers, I do not know what questions the CCCJ will set on the paper for you. But what I can tell you is that I would have taught you the logarithms. So those are our answers. What happens when a variable is an index? So this is what we have left. We have those left. Then we have this other form, this form here that is left. And I think this takes us into the end of the, yeah, those are the solutions that I have here. Right. It takes us to the end of the right. So by next week for sure, we are going to be finished with logarithms and indices, and we're moving into our other area. So congratulations. I mean, after my little pep talk, you guys showed up, and I'm very happy that you showed up. Showed up to a point where we were able to look at some stuff and just have one toops of a piece to finish off. And we can finish off that on Saturday. I wanted to have gotten closer, but that's fine. Are there any final questions before we bid our goodbyes? Any final questions? All right, won't press the point. As soon as the recording is available, I'll send it off to you and send off some notes for you also. Be good and be safe, and thanks for coming out.
Yes, sir. Same to you.
Okay.
Okay, sir.